Hello, my friends. This is the part 2 of DIY robotics. Quick recap on the part 1. We have built a structure with two servos on top of each other. And the objective of this project is to continue building the structure, adding a PI camera on top of the structure, and connect that structure with the brain of the robot. And that's why we have the electronics in this, the first part of this slide. We want to have the structure connected to the internet, and that's why we're talking about IoT, Internet of Things. And finally, we want to add some intelligence to that structure. So the camera can detect faces, can detect objects, and this will be done by programming the Raspberry Pi electronic piece and through Python programming and add the computer vision artificial intelligence. So let's start. So going to the next slide, this is the structure that we have built, and this is the visual on that structure. As you see, like the structure in black here, it's the plastic structure. It's like a $4 structure that you can buy on the internet. And the servo here, it's the blue boxes here. As you see, like we have two servos. The one down here, it's giving the flexibility to the structure to move left and right. The one on top, it's giving the flexibility for the servo for the structure itself to go up and down. And as you see, the two servos, maybe it's more clear on the left screen here. As you see, like the two servos, they have 3 wires connected to each servo. And we're gonna go in the details and explain like what each color means and how we're gonna connect that servo to the brain, the Raspberry Pi. So let's go for the next slide. As you see on this next slide, it's an illustration of the two servos on top of each other, and it's showing like the pan and tilt servos. So as you see, like the pan is actually the servo that it's the base here. It's the one giving the flexibility for the structure or for the robot. I'm gonna call it robot from now on to go left and right. It can go from 0 degree to up to 180, but in our project, we are interested only to give the vision to the robot to go from 30 degrees up to 150. And this is what we call the pan. It's the robot going left and right using that servo. The tilt itself, it's the servo on top going up and down. So down from 30 degrees up to the 150 degrees. And this is what we call the tilt. And that's why it's called the pan and tilt multi-servo structure. The control part is because we want to control those servos. So the brain, and this is where we're talking about the brain, it's the Raspberry Pi. It's the brain that's going to be controlling those servos. And let me go through this quickly. We can have, if you are interested, like I can have one video just giving more details on the Raspberry Pi. So I'm going to go quick on this one. As you see, like the main components of the Raspberry Pi, it's the processor itself. It has a very powerful processor. The Raspberry Pi, I believe it's in the range of 50 to 60 US dollars. And you can find like another technologies that's cheaper, such as the Arduino. It's cheaper than the Raspberry Pi. And again, if you are interested, I can have another video explaining the difference between an Arduino and Raspberry Pi. But high level, like Raspberry Pi, it's very powerful. You can consider it as like mini computer. It has a processor. As you see here, like it has USB, so you can plug a mouse, you can plug like a keyboard to it. You can have those micro HDMI ports where you can uh, plug like the monitors with supporting like 4K displays as well. And it has the power. So the power of this piece of electronics, it can be powered by a USB-C port, and that port is going to feed the electricity to the pins here. You see, like there are multiple pins. Each pin has a number, and those pins actually they are the one that we are going to use to connect the servo wires to the brain to the Raspberry Pi using those pins, and we're going to see it in details. So this very high level description of a Raspberry Pi. The Raspberry Pi itself, it can be programmed using the Python, and as I said, like in the coming videos, we're going to see how we can use Python to program the Raspberry Pi. Going to the next slide, it's in the background, as you see, like we have a servo here. and the 3 wires connected to the servo. And you see here the small paragraph explaining what is a servo. I'm gonna go and I will summarize it later on. So as you see, like the Raspberry Pi as electronics, let me go back. It has the input and output pins. So the pins itself, it's called GPIO. So it's a multi-purpose input and output, or general purpose. That's why it's GP. It's general purpose input and output. So the pin can be an input, passing some information. It can be a sensor giving information to the Raspberry Pi, but it can be an output as well. And the output, it can be an actuator. So what is an actuator? Servo is one example of an actuator. An actuator is actually a motor-driven system, if I want to simply describe it. So the servos are found everywhere, from heavy machinery to power steering to vehicles in your car to robotics and a wide variety of electronics. The servo is actually the very base component of robotics. And let me show you some examples of where we can find the servos. So as you see, like on the right, it's a robot hand here. It has a gripper. And as you see, like the black box here, that controlling the hand to go up and down, it's a servo. The wrist here going left and right, it's a servo. The elbow going as well left and right, up and down, it's a servo as well. The shoulder, the base, you see all these are servos. They are wired and they are connected to the, it's not a Raspberry Pi electronic piece here. It's kind of electronics brain. Not necessarily like Raspberry API. Anyway, it's hidden, I cannot tell. But as you see, like the concept is that you have servos connected through wires to an electronic piece that will be controlling those servos. On the left here, you see this little spider. As you see, like I believe this is a Raspberry Pi on top. And as you see, like the blue boxes here, they are controlling the leg of the spider, and they are wired to the Raspberry Pi. So the Raspberry Pi, through Python programming, it can control those servos. The same can be very complex. It can be existing on a plane. So as you see the tail of the plane here, the airplane, it's controlled by a servo. So you see the servo here. So as you see here in the screen, the Raspberry Pi has no analog output actually. So, but we can simulate it. Like in order to simulate an analog on a Raspberry Pi, we need to use a concept called PWM. And PWM, as you see like in the screen here, it's the P stands for pulse width modulation. W is width and M modulation. So the PWM, it's actually a concept that we can use to simulate an analog output for a Raspberry Pi. So what does that mean? So what we're gonna do, like as what I told you, like the Raspberry Pi through the USB-C, it's gonna be connected to the power, and it's gonna feed the power to the pins. What we can do actually, we can generate a digital signal with a fixed frequency. So as you see, like this 50 hertz frequency, so we can pass that signal with a 50 hertz fixed frequency, and we can play with the modulation itself to simulate that analog output. So I'm gonna make it easy for you. As an example, like if we pass 1 millisecond, so as you see, like we are going to pass, we can control actually the Raspberry Pi, and we can give the command to the Raspberry Pi, and we're gonna see it in the next video, like through the Python. We can tell the Raspberry Pi, I want you to pass to a pin an output signal 1 millisecond. So the duration of that signal is gonna be 1 millisecond, and then it will go down. So you see it's go up for 1 millisecond and then it will go down. And that it will tell the servo that 1 millisecond is actually 0 degree. This is the equivalent of 1 millisecond. If we are passing that signal for 1.5 millisecond, it's 90 degrees. If we are passing this to 2 milliseconds, so if that modulation is gonna last for 2 milliseconds, the servo will know like it has to go 180 degree. So this is what we call the angular rotation. And talking about the three wires, as you see, like we have three colors, and the color, the one that it's brown color, it's actually the minus, it's the ground. So you know, like electricity, you have the plus and minus. So the red is actually the 5-volt electricity power passing in this wire. And the one in brown, it's actually the ground. And the one is left is the orange one, is actually the one it's passing this modulation. So the modulation 1 millisecond, 1.5, 2 millisecond, etc. It's passing in the orange one. So this is how we are simulating an analog output because the Raspberry Pi does not have it. So that's why we are using this concept of PWM to simulate that analog output. On the coming slide, we're gonna go a bit in details of how the Raspberry Pi pin layout look like. So how we connect the sensors, the actuator to the Raspberry Pi pin. But before doing that, we need to explain what is the pin layout. And by pin layout, I actually want to show you this slide here. So as you see, like when I was showing the pin, this is like an illustration of the pin. And as you see, like each pin has a number, 1, 2, 3, 4. So those pins are GPIO pins, general purpose input and output pins. And you see like they are having different functions. So some pins, they are used for getting power. So when you are connecting your Raspberry Pi through USB-C to the power, you can get 5-volt, feed it to that pin number 2, number 4, and there are other pins having the 5-volt. And there are other pins, they are just general purpose pin. They can be used to get data into the Raspberry Pi or send data. And in the Python programming, we can connect to a pin and we can read signal. We can read the electricity coming to that pin. We can actually as well simulate the analog PWM that I have just explained in the previous slide on those pins as well. So in our example, and here I'm gonna switch, I'm gonna show you like the design of how I connected the pan and tilt servos to the pins. But as you see, like the pins here, this is kind of a description. Remember, like we have three wires here, like maybe not necessarily like we have the same colors that I have showed you like in the real example, but assuming that the yellow one is the PWM signal, the red one is actually the 5 voltage, the one having the electricity, the plus, and the black is the ground. So in this design, in the pan and tilt, this is where I'm showing like how I'm connecting each wire to a specific pin. And it is very important to have that connectivity. And I'm gonna show you like live how I'm gonna do that, how I'm gonna connect that structure to the Raspberry Pi live in the coming, and actually in this video. So bear with me, we're going there. But it's very important to understand what each wire stands for. Like again, the one, we have one in red, it's for the voltage, and one for the ground, and another one, the yellow one, is actually having the signal. The most important one is the yellow one, the signal one, because this is where we want to program the Raspberry Pi. If you remember, passing the 1 millisecond, 1.5, so we can tell the servo go 0 degree, 90 degrees, 30 degrees, etc. So let me switch to the fritzing, showing like how I connected the servos and design from design perspective to the Raspberry Pi. So let's go there. So as you see, this tool, I hope I pronounce it correctly, fritzing. It's actually it's a free tool. I use usually like to draw schematic let's concentrate on how we are connecting the servo to the 3 wires to the different ports. So as you see here, like if you count them, like this, the yellow one, as I said, it's the one passing the modulation, the 1 millisecond, 1.5, that will be controlling the degrees of the servo itself, the pan and tilt servo. And those are the pin number 11 and 12. So this is the number 11 for the pan, and this number 12 for the tilt. And the other, it's like the 5 volt. Here we have 5 volt, another one 5 volt, and those are the ground. We have a ground here and the ground here. So this is how I'm designing this. And again, this design is very important because in the next remaining part of the video, I'm gonna show you like how I'm gonna do that wiring by my hand. Like I'm gonna wire the servos to the Raspberry Pi, and I'm gonna follow this design. And in the coming video, I'm gonna show you like we're gonna start programming using Python. So I'm gonna show you like how I can read and pass signal to the port 11 here and the port 12, so I can control the servo to go up and down, the tilt, and the pan servo to go left and right based on the modulation that I'm gonna pass in this yellow wire. So enjoy the remaining of the video, and we'll see you in the next video as well with more Python programming. Thank you.